Selamat siang. Hello everyone. I'm Jongmyoung Lee of our Sea-based Asia network OSEAN. Today I will introduce a structured technique for marine litter policy development. The policy development technique I will introduce today is a conceptual model and result chain. I will show you some examples of marine debris policy developed with these techniques, and we will have some time for practicing them. After the practicing, we will share the practice result of the workshop participants. Using conceptual model as a planning and evaluation tool in conservation was introduced by Margulis et al. In their paper published in Journal Evaluation and Program Planning in 2009. The authors of this paper showed how the tool can be used in developing strategies in planning for conservation projects. They identified the conservation goals and objectives of the project and developed the strategies which can be used to achieve the objectives. Another paper introducing result chains as a tool for conservation action design, management, and the evaluation by Margulis et al. Was published in Journal Ecology and Society in 2013. Authors showed how result chain can be used in designing the conservation action. Conceptual model and result chain was used in developing the Honolulu strategy of US NOAA and UNEP. The Honolulu strategy is a global framework for preventing and management of marine debris. The Honolulu strategy is an outcome document of the 5th International Marine Debris Conference in year 2011. For developing the Honolulu strategy, NOAA and UNEP organized a working group for drafting the strategy and conducted a pre-conference survey for collecting the suggestions from the conference participants. During the 5th International Marine Debris Conference, there was a workshop for developing Honolulu strategy. Dr. Sonu Kong and I participated to this workshop and learned how conceptual model and result chain can be used in marine debris policy development. For conceptual model, we should identify the ecosystem targets we are concerning and what kind of stresses are negatively impacting the targets. And we should identify direct and indirect threats affecting the stressor, and then we can develop the strategy to control the indirect threat in marine debris management. Result chain can be used in examining the liability of the strategy by depicting the expected result from implementing of strategies, and we can understand how the policy can contribute to protection of ecosystem targets. This is an example of conceptual model used in developing the strategies to address accumulated marine debris. You can see that one of the direct threats is lack of removal of accumulated marine debris, and it affects the ecosystem targets of coastal and marine species, habitats, human and economic health, aesthetic and social value with entanglement, ingestion, coral abrasion, food web impact, etc. Indirect threat, like a lack of effective method to locate debris, can be addressed by strategy, developing and promotion of technologies and methods to effectively locate and remove marine debris accumulation. Other strategies were also developed to control the indirect threats of the accumulated marine debris. The results chain were used to examine how the strategies work in immediate and threat reduction result and can contribute to achieve the ecosystem target goals. Next example is from Republic of Korea. We used the conceptual model and result chain in developing the policy on styrofoam buoy debris from aquaculture. The styrofoam buoy was the symbol of fertility of aquaculture field of Korea, but it turned out to be a significant marine debris source in 2010s. We found out that styrofoam buoy was the #1 beach debris item from Korea National Marine Debris Monitoring Program result. To address styrofoam buoy debris, our Southeast Asia network, OSEAN, organized a series of policy development workshops with the stakeholders. Among the workshops, results chain and conceptual model was used in 2012 workshop. Based on the result from previous year's workshop, we drafted the causal relationship and structure of a styrofoam buoy debris issue. The workshop participants helped us with amending the result chain and conceptual model. This is the finalized conceptual model of styrofoam buoy debris management in collaboration with the workshop participants. We can see that there are two main indirect threats in generation of styrofoam buoy debris. They are usually lost during use or discarded after use. And some other factors make these buoys abandoned at sea. We can see overuse, fragility of buoys, poor maintenance, or gear conflict may contribute to buoy loss. Thus, reducing the installation, developing durable buoys, or improving maintenance can be useful strategies to reduce buoy loss. With this result chain, we can understand how strategies bring about immediate result and contribute to the reduction of styrofoam buoy debris in marine environment. For example, reducing installation of the buoy will result in reduction of lost buoy. An education strategy will help raising fishermen's awareness, and we can expect the fishermen will bring back the used buoy from the sea. That's one of the ways for reducing drifting buoys. With the strategies developed by conceptual model and result chain, the potential actions for implementing the strategy were suggested by the workshop participants. And we applied the AHP method to evaluate the priority of the suggested potential actions. After the series of workshops and the research effort, addressing styrofoam buoy was included as a #1 action needed in the second National Plan for Marine Debris Management of Korea. Korea government has been supporting fishermen to exchange styrofoam buoys to durable, environmental friendly buoys. To get the subsidy from the government, fishermen should bring back over 50% of their used buoys. Fishermen can buy certified environment-friendly buoys with the government subsidy for 70% of the market price. From now on, I will introduce the draft for your practice of conceptual model and result chain. I will use beach debris survey result of Labuan Bajo in 2019. The top 10 debris items of Labuan Bajo beaches include the beverage bottle and lid as number one with about 17%. Following items were film fragments and food container and other plastic fragments. These are the typical debris items of Labuan Bajo beaches. You can see the beverage bottle is actually a kind of cup, and the filmed fragment and plastic bags are also kind of a container for ice, water, and food. Of course, they can be used in many purposes. We picked the beverage bottle debris for example of practicing of this policy development tool. We drafted this conceptual model by identifying the indirect threats, including overuse, lack of awareness, and lack of trash collection system. These result in generation of large amount of disposable beverage bottles and accumulation of beverage bottle debris in marine environment. It can cause degradation of aesthetic value of beach and potentially threat the marine biota, degrading catches in fishing nets, blocking drainage system, and causing hygiene problem. Those stressors are affecting ecological targets, including tourism, habitat, fishery, and human safety. With the result chain, we can check how the strategies result in immediately and consequently in threat reduction goal. This is an example of using a table to make a conceptual model on beverage bottle debris. You can use any kind of tool you are familiar with. You can use a paper and pencil or PPT or any other computer program for this work. This is an example of using a table to make a result chain. You can check the liability of a strategy or potential action in marine debris management to reduce the stressor or ecological concern. From now on, we will have a practicing time for you. Please select a debris item you are interested in and draw a conceptual model on that debris item and draw a result chain on that debris item too. And you can suggest the potential actions to reduce the debris based on your conceptual model and result chain. And please share the models and suggestions for the workshop participants. Thank you for your attention.